In this video, we're going to look at which trig functions are positive and negative and which quadrants. So here I'm actually showing you two different ways to determine which functions are positive and negative in which quadrants. First, we'll look at the sine and the cosecant graphs. Remember, these are reciprocals of each other, and flipping a number upside down, like 1/2, the reciprocal is 2. Taking the reciprocal of a number does not change whether it's positive or negative. So sine and cosecant will always have the same sign, cosine and secant will always have the same signs, and tangent and cotangent will always have the same signs. Now, starting with sine, I find it helpful to just know that sine and cosecant are both based on your y variable. So if you're looking at an x and a y axis, then basically whenever the y coordinate or the y value is positive, these functions will be positive. And whenever the y coordinate is negative, these functions will be negative. So above the x-axis is positive for sine and cosecant. For cosine and secant, it's helpful to know that it is based on the x coordinate. So whenever your x values are positive, which happens when you're going to the right on an x and a y axis, you will have a positive function. And whenever you're going to the left for a coordinate, you will have a negative for the function. Now, tangent and cotangent are actually based on the y coordinate divided by the x coordinate. So if both your x and your y are positive, well, a positive divided by a positive is positive. And also, if you have negatives for both x and y, then those double negatives cancel out, and you end up with a positive answer in this quadrant as well. So the tangent and cotangent functions are positive in the first and third quadrant. If either y or x is negative, but not both, that's the second and the fourth quadrant. That's what makes the tangent and cotangent functions negative in these quadrants. Now, this is an alternative way of helping to remember which functions are positive and negative where. Some students find it helpful to remember this phrase: all students take calculus. Now, make sure you remember that we're defining the quadrants as the top right, top left, bottom right. So in that order, it's saying all students take calculus, and I'm looking at the first letter from each of these words to represent one of the functions. So this is saying all of the functions are positive, A for all. S is for sine, so sine is the only function that's positive in the top left if you look at all the functions. Tangent is the only function that's positive in the bottom left if you look at all three of the functions. And cosine is the only function that's positive in this bottom right quadrant, the fourth quadrant, if you look at all the functions. Again, I'm not talking about the reciprocal ones here because the reciprocal ones don't change signs anyways. I'm just focusing on the sine, cosine, and tangent functions when I'm using this phrase. Now, the way we use this information is sometimes we only care about whether a function is positive or negative for a certain angle. So they may ask you about something like 150 degrees. You would first say, all right, well, 150 degrees should be up here in the second quadrant. So if they say what's sine of 150 degrees, I know that that one would be positive. But if we were talking about cosine of 150 degrees, that would be negative. And then if they said tangent or cotangent of 150 degrees, that would also be negative. So sometimes it's helpful just to know whether a function is positive or negative for a certain angle or a certain quadrant. So here's our first example. They want us to state whether the functions are positive or negative for sine, cosine, and tangent. And they're asking about values of theta in the interval between 0 and 90 degrees. Well, remember that if we're talking about our x and y axis or our unit circle, 0 and 90 degrees are the ones pointing to the right and straight up. The other ones would be 180 degrees, this one's also good to know, and 270 degrees. So when they say angles in the interval from 0 to 90, they're saying they want to know about the ones that are in between 0 and 90 degrees. This is not a coordinate, this is an interval of angles. So they're asking us about the trig functions in the first quadrant. Well, from looking at the table on the last slide or by using the rule for all students take calculus, in this first quadrant, we said all of the functions are positive. So sine, cosine, and tangent should all be positive since this range of angles is in quadrant 1. Now, the actual value of the trig functions will vary, of course, because whether we're talking about 1 degree or 43 degrees, anything between 0 and 90, these individual numbers will change, but what we have identified is that all three of the functions are positive. Here we have three more quick examples, but this time they're not asking us for all the trig functions, they're only asking us for one of the trig functions at a time. So our first step will be to identify which quadrant our angles land in. So 100 degrees, I know that that's between 90 and 180, so I know that this one is up here in the second quadrant. The exact location in the second quadrant doesn't really matter. As long as I know that I'm in the second quadrant, I know that the sine function will be positive because we said sine is positive whenever y is positive. So anything going up would be positive for that one. Now this does get a little bit trickier when we start dealing with the radian measurements because it can be hard to determine which quadrant the angle lands in. So one thing I find helpful is to kind of ignore the pi and just focus on the fraction that you have out front of it. So in this case, 11 over 6 is a number very close to 2. 12 over 6 would equal 2. So it's very close to 2, but it's slightly less than it. And if you remember, or if you look at your unit circle, the 2 pi value is what you hit when you go all the way back around. So 0 and 2 pi are actually the same, but by being just a little bit less than 2 pi, that means I'm down here in this fourth quadrant. And the cotangent function in the fourth quadrant, it's all students take calculus. Cosine is positive in this quadrant, but everything else is negative. So I know that both tangent and cotangent have negative answers in quadrant 4. Here's another one just to repeat this process. So now I'm going to ignore the pi again and just focus on the fraction 4/3. Well, 4/3 is just a little bit bigger than 1, but it's not as big as 1.5. So I know that now I must be landing somewhere in this quadrant. And then the rule for cosine, it's all students take, so tangent and cotangent as a result are positive down here. That means cosine must be negative here. Cosine is only positive on the right-hand side if you look back at the diagrams. Now we'll look at how you can be given an ordered pair or a coordinate and then evaluate all of the trig functions based on that x and the y value. So first, make a right triangle out of the coordinate you were given. The x-coordinate will be the base of the triangle and the y-coordinate will be the height of the triangle. Make sure that from the point you are drawing a vertical line to connect to the x-axis and then a diagonal line from the point back to the origin. That should create the shape of your triangle. Don't connect it to anything else. It's always connected to the x-axis and the origin. Do be mindful of the directions from the origin, like if you're moving left or right for an x value, that'll be indicated by whether the x and the y coordinates are positive or negative. So even though it doesn't make sense to have a negative side length on a triangle, the direction we're moving from the origin will still affect what our answers for sine, cosine, tangent, cosecant, secant, and cotangent will be, because it'll change whether those functions end up being positive or negative. So I like to put the negative signs on the triangle lengths just to make sure that I'm getting the right answer when I evaluate the trig functions at the end. Since we'll have the base and the height of the triangle, you should be able to find the r value, which is either the hypotenuse or the radius, depending on whether you're thinking of this as a circle passing through the point or the triangle hitting the point. So we call that value r for the length of the hypotenuse / radius. And then if you find that using the Pythagorean theorem, you should be able to just plug in your x and y coordinates and your radius value to evaluate any of the 6 trig functions that they might ask you for. So now here's an example where we are being given the point P, which has an x value of -3 and a y value of 4. So if we plotted that graph on an x and y axis, we should end up with a point somewhere around here. Left 3 units and up 4 units. So connect this dot to the x-axis. You should have a vertical line, and then have a diagonal line connecting you back to the origin. This will create a triangle for you. And it should always be a right triangle since we have perpendicular lines for the vertical one and the horizontal one from the axis. Well, the base of the triangle is the x value. So I have -3. Like I said, the negative doesn't make sense other than to indicate that I'm going left instead of right 3. That's the only reason I'm keeping track of the signs. And then the height of my triangle is this y-coordinate of 4. So since I have 2 of the sides of a right triangle, we can find the third side using the Pythagorean theorem. So you would have side squared plus side squared equals, and then whether you call this the hypotenuse or the radius, either way is fine. If you think of it as a circle that's going around and touching that point, that's why I'm still referring to this as the r value. There is kind of a circle that's extending from the center at the origin and then passing through that point. But if you solve this one, you should end up with r is equal to 5. Your r value should always be positive. Since you're always squaring the 2 numbers and adding them together, you should always get a positive radius for this. So once you have all 3 sides of the triangle filled in, we're just using the list of rules I gave you on the last slide that showed sine of theta is equal to y over r. So I have 4/5. cosine is equal to x over r. And this is where it's very helpful to have the negative signs on here, because if I had just written positive 3, I would have gotten the sign wrong for this function. So my x value is negative 3, and my radius is 5. The other way you could have done this is by keeping all of the sides of the triangle positive, and then using the all students take calculus rule at the end to go through and mark which ones should have been negative instead of positive. And then tangent is equal to the y value divided by the x value. So I end up with negative 4/3. Now for the reciprocal functions, remember we can just flip these numbers upside down. I didn't give any examples here that needed to be rationalized or simplified, so it's pretty easy to just go through and take the reciprocal of all of these numbers. Make sure you know which functions are reciprocals of each other though. So then we have secant, which is the reciprocal of cosine. If you flip negative 3/5, you get negative 5/3. And then cotangent, the reciprocal of tangent, is equal to negative 3/4. So you are given an x and a y value, we found r, and then we just plug into the rules I listed for x, y, and r to evaluate all 6 of the trig functions. This last example, I'm going to show a similar process to what we did in the last one, but here we actually have values that we can't make a triangle out of. Since my x value is 0, I don't have a base length for my triangle, so I just have from the origin passing down to the point 0, negative 5. So instead I'm going to focus more on this one as a circle. Since I can't really draw a triangle here, it's helpful to think of this as a circle. Well, I still have an x and a y value. I have x is 0, and I have y is negative 5. And if you look at the circle we've drawn, to go from the center to the point 0, negative 5, that means the circle has a radius of 5. Whenever one of the numbers is 0, you will not be able to draw a triangle, and the radius will just be the absolute value of whichever number you have. And that's coming from the distance from 0, 0 to 0, negative 5. So now again, I have x, y, and r. So this one actually required less work since I didn't have to do the Pythagorean theorem to find r. Now I can just go right into writing the answers for all the trig functions. So first we have sine, which is y divided by r. Well, negative 5 divided by 5, if you reduce that fraction, that's actually just equal to negative 1. Cosine is x divided by r. Well, 0 divided by 5 is just 0. And then y divided by x, negative 5 divided by 0. Whenever you have 0 in the bottom of the fraction, that is undefined, which is okay to just abbreviate as UND. Cosecant will be the reciprocal of these values. So if you want, you can think of it as r over y. You can evaluate it out that way, or just flip the number I have here. Negative 1, the reciprocal, is still negative 1. These are kind of tricky because now I have 0, and it was divided by 5, but now I'm doing it the other way around, 5 divided by 0. So when you flip this fraction upside down, this actually ends up being undefined when you take the reciprocal. And vice versa, if you had an undefined value, this came from negative 5 divided by 0, but now I'm flipping it. So it's 0 over negative 5. The reciprocal of undefined is actually 0. So you can see that happening both ways. The reciprocal of 0 is undefined, and vice versa. So that's it for the notes. If you cannot draw a triangle, just try to think of the circle that's passing through the point and identify the radius, and then use the same x, y, and r values for sine, cosine, and tangent. So now you should be comfortable with identifying which trig functions are positive and negative in which quadrants, and you should be able to evaluate the trig functions, including whether they're positive or negative, for given points on a x and y plot.